Okay, well, hello everybody, and welcome to this month's Phoenix Perlmongers group. I'm presenting the Perl Debugger, or Perl's Sandbox, basically. So first, real quick, we're going to go through the basic operations of the Perl Debugger, and it is really just an intro. There are a lot more functions and usability to it, so if you're really interested in it, I would highly recommend reading the man page. It's just man Perl debug. I should have made a slide for that, but I always started this way. The first steps of any debugging, you need to use strict and use warning. This really has nothing to do with the debugger itself. It's just if you're not doing this, you need to take a few steps back first and revisit your coding practices before trying to debug. So basically, the debugger, what is a debugger? Well, the debugger it's not a program. Basically, all it does is it compiles your code and it stops right before it hands it off to the interpreter, and it lets you sit right there, and you are able to control what the interpreter does or how the interpreter progresses. So that's basically what the debugger is. Why don't more people use it or aren't even aware of it? Well, I guess that's the first point. A lot of people are just not aware that a debugger is standard with every distro of Perl. And usually, at least I've always found, I don't use the debugger because the error message tells me enough that I know exactly where, what's going on. It's only usually in really rare cases where there's some weird logic where I really need to break out the debugger and step through the code line by line. And of course, before I really learned how to use the debugger and use it a lot, especially as a sandbox, I would just put print statements everywhere to make sure that, is this actually what I think it is? And then it was a whole big of a mess, but eventually I would figure out what I was doing wrong. And I was doing the hard, the heavy lifting that the debugger does for you by just typing in print this, print that. So usually just real quick reasons why most people don't use the debugger. So calling the debugger, it's fairly simple. It's just Perl -d and then your program name. And that's pretty much it. You can also do Perl -d -e and then give it an expression. So anything that anything it can eval, excuse me. And later on you'll see I usually just pass it a number. Also, if you have TK installed, this is an awesome one. It's -d ptkdb and then the program name. And it is rather archaic looking, but it works very well. It's very feature rich. And that's if you really don't want to learn how to do it from the command line, and you want the pretty window, the TK version of the debugger, or the front end, I guess I would call it. It's just fantastic. So the basics, the first basics, once you've started the debugger, is how to get out of it. It's just Q. That's it. It's not quit. It's not exit. It's not /Q. So usually it takes me about 4 tries to get out of it because I can't remember that it's just Q. But Q and enter gets you out of the debugger. H stands for help, of course, and it's basically H and then the command. And so here's a little show of the list command. And as you can see, it shows you all the, the arguments you can pass to it. I'll be going over the list command later on, but not in this detail. So if you're looking at a command, use the help, and it'll get you right on the, along the way. The other good one to know is R. It basically, if you're in the middle of the program and you realize you've either gone too far, or you need to back up a few steps, or you need to back up all the way, R, it reloads everything and lets you come in back from the beginning. So that's very useful, especially if you're using modules and you've made a change to the module. Just because you've made a change to the module and you've saved it doesn't mean that the debugger knows about it, because it pulled it into memory before you made the changes. So you'd have to use the R so it can refresh all that information back into memory. So basically, what do we see when we get into the debugger? It's just the screen. That's pretty much the first thing you'll always see, and I have a little program there, and the first line we see. Basically, it tells us what package we're in, the file name, and also the line number that we're on. It's very important to notice the debugger shows you the line that it's on, not the line that it's just processed. So it's not good to know this has not been executed yet. At this step, you don't have a CGI object. You just have the debugger saying, hey, this will be the next thing that I do unless you tell me something different. The only other thing is in the line, it gives you a number next to the prompt. That's your command number. This is used for if you want to repeat a command, and I'll go over that in a little bit. So that's basically what you see. So here we have a little snippet of code where we saw it. So how do you walk through it? You have N, which is next, and it basically means step over. So if we're at the, I'll use my pointer, if we're at the first line there and we hit N, it goes on to the next line. So it goes on, it creates our CGI object, and then it goes to the if statement, or gets ready to do the if statement. The other way of walking around is the S for step into. Well, here, we'll just show you. As you can see, again, we start the program, we're stepping into it, but instead of going to our next line of code, we actually step into, you can see, into the CGI package. We're in the new subroutine, and we're basically on the first line of the new. So, basically it steps you right into the next actual line that the Perl interpreter will execute. But in all honesty, you really don't want to be in there. You want to get over the creation of that and get on with your own code. So basically, once you've used either S or N, then when you hit enter, you're just repeating that last one. So, and it's the only commands that does it with. So it's just a nice little shortcut for stepping through your code. R is for returning. So if, like we did just then, we stepped into the CGI module, and we really don't want to be there, and we don't want to step through, God only knows how many lines of code there's going to be there. We simply hit R, and it brings us right back to our, it brings us back out of there to where we want to be again on in our code. So the C, it's basically C allows you to continue. It's either C and either you can, if you just hit C, it'll go either to the breakpoint or to the end of the program, or if you give it a line number, it'll continue to that line number, or the closest it can get to that line number, depending on how it sees it. So again, that's just the way that you move through the program. So once you're in it, a couple of useful things to know is P is just basically print. So I have a data structure here, and here we go back into our Perl into the debugger, and so here's the data structure. It's saying, well, this is the line that I see, and so then you hit P and then the hash, and of course nothing happens. And so I got kind of confused and concerned. Maybe I'm using P wrong, so I did P, and I went directly one of the hashes, and I'm still getting anything. Anybody know why I'm not getting anything right now?
Line has been executed.
Exactly. Right now we're sitting on this line. Perl's telling me this is the next line that's going to do. It doesn't know about data yet. It doesn't exist yet. So if you do something and nothing's happening, make sure that you've actually executed the command that you're trying to investigate. So here we started it again. Then we hit N for next, so then it's processed the entire data structure, and now we can print it out. And obviously, it just does exactly what print would do. If you give it, a hash, it just prints it all in one, string. Go ahead.
So I have a question.
Sure.
So when you hit the N right there,
yes,
it looks like the next line's out there, but then if you hit, okay, so you're saying that before you hit it the other way around, right?
Right. In the see here, I said, oh, I see. Yeah, it sees my data structure, but I never hit N. I never told it actually process the data structure.
Okay, gotcha.
It just, I'm like, oh, I want to access this thing, but it doesn't exist yet.
Right.
So
yeah, I was like looking at this one, I'm like, this will work.
yeah, well, exactly, and you will do that. You'll be looking at it and like, oh yeah, I need to access that. I want to see that, and nothing's happening, and it's because, well, you haven't processed it yet, and it's just a little thing to get used to, but once you do, it's no longer a problem. Okay, X, really very useful. It basically evaluates whatever you're giving it in list context. So basically, same thing as we just did with the print, except for you see when X, it does it in a list context. It gives you the line numbers there, and then it prints out. So it does a little bit better representation of the hash. Instead of putting it all, like print puts it all into one string, it actually says, oh, this is one element, this is the other. The nice thing with this is, if you guys use data dumper a lot, if you pass this as a hash reference, then it says, oh, this is a hash reference and this is what it's made out of. And it looks almost identical. Well, the data dumper one's a little bit more made up, but it's basically a very rudimentary data dumper without having to actually load data dumper. Now, mind you, it only does this for one level, where data dumper, expands it all the way out. X only does the first level. but it's for more often than not, that's all that you really need. So yeah, X is just, it's much easier than print because it handles variables the way that you really want to see the data. So just to beat X to death here. Basically we're in the debugger. I set int to 1, and then just to show that P actually works, I print out 1, and then I just show that P is print, and I print it out again. And so this is how X does it. You hit X in the variable, says, okay, this is the first line, and it's a 1. You can also do it, it evaluates this entire expression. So setting it equal to 2, and then hit the X beforehand, it says, oh, well, we have a 2. So instead of doing it in 2 steps where you say int is equal to 2 and then x int, you can just do x int equals 2. But you do have to be careful with that because sometimes, some especially like regular expressions, they don't return what you want it to return. It returns like the number of matches. So you have to keep that in mind, what you're actually getting out of it. But it's a nice shorthand for saying what did my last command actually do, return. Then the next really cool thing, and this is where the command numbers come in handy, is the exclamation mark. Exclamation mark number, it repeats that command. So here, basically, if I want to reset int back to 1, I can either rewrite the entire command or basically just say exclamation mark 15, and it says, okay, well, this is what I'm doing. And then to confirm it, I just hit x int, and it confirms that it set it back to 1. So yeah, the exclamation mark becomes really,
That also works in Bash.
Oh, really?
Yeah.
I did not know that. That's cool. Yeah. I never knew that worked in Bash. This was the first time. Yeah, it's the first time that I'd ever seen it actually work that way. So, and it's when you're doing something repeatedly over and over again. Really, I don't know if that works in here, but yeah, with one exclamation mark, it definitely helps with when you're doing repetitive tasks. Okay, list, this is great. Basically, list does that. It lists a window, and the default is if you just hit L, there's an internal pointer, and if you haven't done anything with a list or a view, the pointer is where you're at, and it lists 10 lines around that. So here, as you can see, as you can see, we're on line number 3. That's where the interpreter currently is at, and it shows us the next 10 lines. The internal pointer at this point in time now is at 13. So if we just hit list again, it starts at 13 and gives us the next 10 lines. And of course, if you keep hitting list over and over again, it'll just keep going, through the entire program. Now, obviously, you can list in many different ways, but I just check out the help page on that because it's fairly rudimentary, but it just take way too long to try to explain. Now, list just goes from the line that you're at or the line that you specified and 10 down. View kind of tries to look around where you're at. What it'll do is if you give it a view and a number, it'll look at that number and it'll show you the previous 3 numbers and the following 7 lines and the following 6 lines. So you have a 10-line window, but it's around the line that you're looking for. And again, it also uses that internal pointer. So here we have here we did a list. So the internal pointer is at 13. So now when we hit view with no argument, we're centered basically on 13, meaning it shows us 10 through 12, which is the 3 previous lines, and then 14 through 19, which are the next 6 lines. So it tries to give you more, instead of where list just shows you one after the other, the view tries to say this is around where you are. Also, and you can give it an argument so that basically you can say, okay, I want to view on 10. So again, 10's it's 10, the 3 previous lines, and the 6 lines afterwards. To reset the internal pointer, it's just the dot. You dot and enter, and then when we hit V, we notice we're right at the beginning of the program again, because by hitting the dot, you just set it back to 1, point back to the first line of the program. Okay, other basics, breakpoints, very important. If you know that whatever's happening is at line 100 and something, you can just put a breakpoint at 100 and something. Now you can set breakpoints in many more ways, but again, I would refer to either the help docs or the man page. The capital B removes the breakpoint. So if you either give it a specific one, it removes that one. If you give it an asterisk, it removes all breakpoints. So it's a good way of just cleaning up. Other very useful is the W, and then an expression that allows you to set up a watch. So like in this sense, we're on the line, which is basically, it's going to create a variable called stop running equal to 0. So I set up a watch for stop running. And basically when you step into it and the value change, it says, okay, this has changed. The old value was, well, nothing because it was undefined, it didn't exist. And the new value is 0. So, and then it's great if you're in a loop and, you know, every time something changes in that loop, it just tells you, oh, this has changed, this has changed. Capital L lists all of the breakpoints and the watches that you've set up. The reason there's an asterisk there, it also shows you any actions that you've set up, and that's a little bit beyond this discussion. So, but just nice to be aware of so you know where your breakpoints and watches are. Now these are a little bit more advanced, but just really cool to know about. Capital M, it lists you all the modules, the versions, and the locations where those modules are. So if you just hit M, it spits out a huge list of everything. Lowercase m is the methods that are available to you right now. Capital S, and of course a pattern, gives you all the subroutines that you can call right at this minute. And V is any variables that are instantiated and available to you. So lots and lots of output, but a great way to be able to see exactly what's actually happening. So basically, this is the part that I want to drive home, is just Perl as a sandbox. As I said, to start Perl, we need to give it something to evaluate. And the easiest way to do it is you just give it a number. And you can either do -d, -e1, or as I always do it, is just all glom together. And that's great, because what it'll do is it'll process the 1, or it's waiting for you to tell it to process the 1, which you'll never do. But then now you're basically at a Perl interpreter line. Every time you write something in there, Perl will evaluate it and give you back what it did in that line. It's very useful, and I'll show you more in a second. The reason why not just doing D, well, as said, the debugger is a program. The debugger is not a program. If you just give it D, it doesn't know what to do with itself. So what it does is it compiles, well, itself, and then it waits like a step before compiling is done, where you could actually put more stuff, but it'll just sit there and wait until you hit Control D, when it'll actually then drop you out to the little debugging shell. And so, I guess you can just do Perl -D and then hit Control D, but it's just so much easier to type in the DE1 or DE0 or DE whatever you feel like. One of the biggest pushbacks that I get, and I can see this, is the reason is why not just use a script? You can write a quick little 3-liner and you can test it out there. Well, one of the quick examples that I had is a while back I was working with interfacing with a mail server from the command line, and for whatever reason it required the email address to be sent in base 64. And so you started the Perl debugger, imported MIME base 64 and just said print me out, encode my email address in base 64. Well, if we did a script, then I always started with use script, use warnings, the exact same lines as these two, and then I'd have to save it, and then I can run it. So it's basically your own personal preference, which one you ever want to do. But the thing is, you can leave this up and running in one of your terminals, and then just when you need to test something out or see something, you can just pop it in there, and boom, immediately happens. You don't have to open up a new file, write in whatever you want, save the file, then execute it. Or in my case, then I also have to make sure that it's in the right mode. Then I have to change mode on it, and I don't know. It just seems to take much longer for me now. So real life example. This is a snippet of a program that I have, and basically, yes, I renamed it. This is the file that you were looking for. Basically, I have a program. It looks through some XML files. It gets some information out of it, and then compares it to files that are in my file directory. And it tries to match them to say, yes, these two are the same. And it used to have all kinds of logic in it, and then all of a sudden I realized, oh, I just need to strip everything out of it except for the letters and numbers, and then compare that string, and that'll tell me whether this is the same information. And this is the final format, but I'll show you how I eventually got there. And one of the easy ways to say is, well, why didn't you just run the dumb program, and then go through it and make sure it was doing the right thing? Well, the main reasons was the program takes quite a bit of time to run. It has to read through a whole bunch of files and then do a couple of other things, and then finally it tries to compare the file names. The other problem is if it does find a match, it goes and does what it needs to, and then it destroys the original file. So if you screwed this up, it's not exactly, it's not something you can undo, recover from very easily.
Control Z.
Well, yeah, just put it in the background, and that way you don't have to look at it while it's destroying your files. Sure. But so basically, I started the debugger, and I created a variable x, and I just put in some junk. And basically here, I just needed the regular expression, which this one works correctly. But you'll see how infantile some of my regular expression work is, because it took me several times to get there. Basically, all I want to string out of this is that this has ABC 1, 2, 3, nothing else. So the first stab at it, well, then I just printed it out to make sure, yeah, I do have, that's what is in an X. And so my first stab at it was this regular expression, which, needless to say, isn't going to work because I forgot about the numbers to begin with. And, well, we'll see what happens. So I then, I've run it, and now I tell it, okay, let's print out X again. So instead of typing X, $X, I just redo number 2. And it shows me, well, it kind of worked. It took out the space, but nothing else. And the reason was I didn't include the G. So, well, let's run the dumb thing again. So I updated my regular expression, ran the command, and then again, exclamation mark 2, and it said, oh, great, now I have ABC, because I forgot the numbers. So then I did exclamation mark 1 to reset my variable, and I wrote my, and then print it out again just in case. And here I thought, okay, here I'm just going to take a shortcut instead of running my regular expression and then printing out X. I'm just going to do, eval the entire argument, and then that's when I realized it returns the number of matches, not, the final string. So here I finally have the right regular expression. So when I print out X, now I have what I want. I just have the letters and the numbers, and life is good. And as you can see, that's what I have plugged in here. And so, yeah, if I would have actually sat down and thought about this first, I probably could have done this maybe 1 or 2 iterations, but it took me, 1, 2, 3, okay, it took me 3 times to get it. To run this program 3 times, I would have stopped trying. I would have just left it, the halfway that it was, and just dealt with the occasional hiccups by hand. So anyway, another great example. This is within, I have my own little budgeting program. And this is where I use it the most. Is basically I'm looking at this, a very contrived example, but this is how I use it the most, especially when I'm looking at someone else's code. I have this line, and basically I have an account object, and I get balance by status, and that pops it into this hash. And I'm like, and then you need to use the hash, and I want to see, well, what is in status exactly? Well, the first instinct is, well, we'll just put a print status underneath there, or print it out in a nice way. But this is, on a server, it does HTML. So then I'd have to remember, oh, I need to first print out the, context header, so that it actually prints it correctly to the browser and it doesn't, blow up at me. And then the other idea is like, oh, well, then you can just run it through the debugger the old-fashioned way. But the problem is that to get to this line, you need all types of environmental variables that the browser sets up for you, and of course the user needs to be logged in, which from the command line, you could do it, but it's just a lot of work to get to this line just to see what the stupid this hash is. So what you do is you execute the debugger, and here you can see I've augmented a little bit. I added the -i, which basically says my modules are located in this directory. So my home directory, CGI bin, banking. So what it does, it pops that onto the inc array, so that when I tell it to, I want to use banking account, it knows where to find that. And then I, of course, have the -de0, which says go into the debugger. So now we're in the debugger, and I just use the capital M real quick, and there you can see it has my module loaded, and it actually, you can see where it's located at. It found it in the right place. And the reason, again, why I had to do this, my home directory, CGI bin banking, is not in the path. So without this line, it would never have found the correct module that I'm trying to look into. And so basically then that's all we need to do is we need to create the object. So I know that this account object is for account ID 13. And then all I do is say, okay, evaluate this expression, account balance by status. And then it prints out what it is. And so what we see is we have this information, this is my hash, and that's what status is. So within a few short commands, I'm able, because I knew everything else about this object, I just wanted to see what the output actually looks like. I was able to just run these commands real quick. And now, mentally, while I'm looking at the code, I know for a fact this is exactly what status looks like. And now it's a lot easier to then go through the subsequent lines. And So this is really the most powerful use of the sandbox, is that you can quickly jump into the environment that you're working in. And if you're just missing the one piece of information, you can basically plug in code to get that piece of information without having to run the entire program around it or figure out how to get to that piece of program. So last but not least, caveat emptor. Basically user beware. Just because Perl catches things, it doesn't necessarily mean that the debugger will. Remember, you stop at the end of compile time, and especially if you're using it as a sandbox, you haven't given it anything to compile. So there are some checks that it just can't do because it doesn't know what you're going to provide it. And I wish I could remember how I did this, but at one point in time, I almost took down a development server because I generated an infinite loop that I didn't see coming, that actually Perl itself, under normal circumstance, caught, but the debugger didn't. And basically, just beware. You're in a state of Perl which is a little bit more unstable, and you can do things. The Perl allows you to do many bad things anyway if you're not careful. So the debugger is just a little bit more on the crazy side. Strict and warnings are not a play. Even if you say use strict, it's like just entering a nothing command, because it's not going to tell you that you've just used a variable that you haven't used before. So just to be aware of. Commands need to be in one line. This is kind of the most irritating part, but again, you're in the middle of a compile time environment. So, it needs to be in one long line. Or if you do want to break it up, you need to have the backslashes at the end of each line, and it knows to wait until, it interprets all of this as one line. Finally, a lot of environments that you'll run into when you start the Perl debugger, you'll notice the arrows do not work the way that you want them to work. Actually, they won't really work at all. You won't have up or down. You won't even have backspace. To get around that, you just need to install these two modules. And really, I would recommend Googling on that, and they'll have more instructions. So, and that's basically it for the Perl debugger. And if you have any questions, I will field them now. Thank you.
If you use X to look at a hash reference, and it's a hash of arrays or hash of hashes, what you'll see will be like, I guess hash.
Yeah,
little like
yeah.
string reps.
So if so we have since I can't see the screen, someone's going to have to tell me when I screw up.
I'm sure someone would definitely do that.
So, actually, I'm sorry. It does do that.
Yeah. Oh, it's
But
nice. It's recursive.
It did, but I have seen it in cases. Maybe it cuts off at a certain level of recursion. I have seen it basically stop, and then it just stops and says, "Oh, it's a hash here." So.
Might be something this has a newer version of Perl.
Yeah, possibly. Yeah. True.
Well, there you go.
So can you step through a regular expression?
Yes, and I didn't cover that because there's a specific way of opening up the debugger, saying that I want to parse a regular expression. I want to debug a regular expression, and actually this will be man Perl debug.
It's got to be my major fail. Always.
Oh yeah, okay. RE debug enables you to see the gory details of how Perl regular expression engines work. Anything that says gory, I didn't think belonged in an intro too. But yes, from what I understand and from what I've read, it's actually fairly exhaustive, and you can definitely get all geeky with your regular expressions through it. But
Yeah, semi-related is like, what is it? Is it called like regex explain, or there's some CPAN module that's really cool. You can like give it a regex and say explain this, and it'll like it just literally splits the whole regex up line by line.
So it was like this episode.
Yeah.
That's pretty cool.
any other questions?
I had a comment about breakpoints.
Mm-hmm.
You can also do like $, capital D, capital B, : : single equals 1. in your file.
Okay.
And the reason I remember that so well is that I hate trying to figure out where to set a breakpoint, especially if you have something that has multiple modules and they all inherit or whatever. If you do that, where if you think it's going to break right after that line, you save that in your actual source code and then run the debugger, and there'll be a breakpoint set there.
So it's what is it again? DB.
::single equals 1.
So basically, you save that into your file, and when it hits that, it becomes. So basically, you run the program normally, and the minute that it hits that, it turns.
Yeah, that basically gets set. The debugger knows to set a breakpoint there.
Still have to run the debugger, but it.
Okay, I got you.
Continues till it hits that.
Okay, that's actually very good to know.
It's cool. It's like a hard breakpoint.
That is nice. And yeah, as far as setting breakpoints, you don't have to know the line number. You can say break, and I've never figured out exactly the syntax of it because I don't use it that often. But it's like break when you get to this package, this method, and this package. So you don't even so you don't even really need to know the line number. You just need to know the method you want to stop in. So it's. Yeah, again, I have this this open with the environment loaded for for what I'm working in, and then that way I can just say, what is that exactly? Well, just create that object and spit this out. That's how I use it for the most part. Yeah, and the reason why I went to using it that way is that I found that the stepping through the program really only works when you're working in I don't want to say a simple program, but more of a program that's one file or a couple of files that doesn't have a lot of security or is meant to be used through the web browser, or uses a lot of very convoluted external code. In that case, it works better to basically you see the code that you're looking at and then just use the sandbox to kind of pick at individual commands.